Hey everybody, this is Larry, this is me going Q3 of the weekly contest 364, Beautiful Towers 2. So I actually solved this one and Q2 together because they're the same problem with different constraints. And I figure I just do, and this is what I did during the contest, so I don't mean to just be lazy about it. But yeah, Q2 you can do with brute force, but this one for Q3, n is 10 to the 5th, and so you have to be a little bit more careful. Or, you cannot be brute force because that's n squared, and n squared is going to be too slow for this one. So yeah, so the idea here is, the way that I would think about it is just try to figure out a way to reuse calculations that we've done before, right? Recall that if you did during Q2, the idea is that brute force on each of the height, each index being the top of the mountain, and then you just go left and right and kind of do things, right? From here, well, one thing that I was trying to do is figure out, okay, can we figure out at least just the one side of it, right? Just the left side. If this is the peak, then how do we get what is the height from the left side and so forth, and then going up. And really, that's pretty much it. I think. So the way that I did this is a little bit awkward for sure, and maybe and this takes a bit of time. So yeah, but the idea that because you can actually do this with a mono stack, but I did not do it with mono stack. I did it with a sort list in the contest. I'm going to break this into two parts. One is to one is to do what I showed you, and then the second one is the mono stack. We'll bring it into two parts, and then we'll go over the ideas. We'll do the live portion we'll do additional live portion of the mono stack in part 2. Okay, so first of all, the idea I was saying is that, okay, so given a certain max height, what do I want to do, right? What I want to do is just to build out just the one side, like the prefix or suffix, and then, because if you just calculate the sloping upwards and then sloping downwards, then we can combine them later on, right? So basically for this, the idea here is that, okay, well, if 6 is the peak on the left side, the total sum is going to be 6. Otherwise, the 5 is smaller, so it's just going to be 5 is smaller, so then looking at this 6 is going to be 5, so we convert it to a 5, right? And then 3 is even smaller, so then we convert it to 3, something like this, and then so forth all the way down, right? That's basically the idea, and just kind of go 9, and then 9 is okay, but then now we have a 2, we have to pop the 9, we have to pop the 3, pop the 3, pop the 3, right? 7 is fine. And that's basically the idea, and maybe you could have prefix and it's fine along the way, and if you kind of look at it in that way, it is going to be monotonically increasing, hence we can do a mono stack. I did not do it quite this way during the contest because I was just too confused, to be honest, and I just wanted to get it over with. But basically using that idea, I just used this sorted list, and I wrote a function for only calculating one side, and then the other side is just going to be the reverse, and then you reverse the answer or something like this, as you can see, and then you just take the best of combining two of those together to make a mountain, right? So okay, so now simplifying to just looking at one side. Ooh, what did I click on? My mouse sometimes goes crazy. Sorry, friends, hang on. My mouse sometimes goes crazy for sure. Yeah, so we start at 0, and then what I did in this idea is just to use a heap, right? Basically, every time I see a smaller number, I just pop off stuff, or I get off the heap from the previous stuff. I did this in a very expensive sorted list kind of way, as you can kind of see here. But basically, the idea is that, okay, we try to find the entry where h is there, and then we either remove it or set the count equal to 1, and then we add it back in, right? So this is basically just incrementing it with h, right? And then here it's basically removing all the values that are bigger than in the heap. I use the sorted list for a heap because then it allows us to do these kind of in heap updates, if you will. It's the same idea, a little bit complexity difference, but yeah. And basically for every number that's bigger, we remove it, and then we running added to the running count. And the reason why we have these count here is so that we can have a compression, right? Because the idea is that for every number that, or every number that we index that we added in, we only want to remove it once. So if you do it in a little bit lazy way, it's very easy to get a TLE because you just keep on removing the same number, add in, remove. Like for example, if you have something like 5, something like this, you solve a 4, you have a 4, and then now you pop the 4, right? And that's one operation. Next you have a 3, you have to remove, and that's going to be slow if you kind of keep on doing it, right? So then the idea here is that 5 and 4, now this has a, we update the 5, but then now we have a 3. You remove all these at once, right? You do this in one operation. I didn't really highlight it in this ASCII art, but that's basically the idea. So this is just incrementing 1 to the current number, and then this is just removing everything that's bigger than the heap and then adding a count. I think I could have actually swapped these in a different way. Maybe I should have done that, then it would make something that's slightly cleaner, or else I wouldn't have had to worry about this because we would remove them anyway. So but yeah, and then after that we added to the prefix the total. What is the total, right? The total we added to h, and we also subtracted from the delta from what we pop, right? So that's basically the idea. But yeah, so that's basically the idea for this problem, is that we basically keep on popping things off the top. And I'm going to rewrite this now, with us here live, just to kind of, because, during the contest, what I optimized for is the solving time, as you can see, as I was trying to anyway. But, now that I have more time, I'll try to do it the correct way, because what's the complexity here, right? Or before I made some well, for each height we do a lot of different bisects, but it's going to be linear number, at most amortized constant number of bisections. So this is going to be n log n, but one with a heavy constant, to be fair. And I looked at the submission time, and this took actually like 8.5 seconds, which is very scary. So out of 10 seconds for timing out, at least in Python or Leetcode, right? So but yeah, you can optimize this to linear time by using a mono stack. But yeah, so basically here is while length of stack is greater than 0, and the same as this really. If this is greater than h, right, then p count is equal to, I think this is st -1, right? Delta, I guess this part is actually pretty much the same. So we want to remove this, right? And then, I guess we'll just call it running, just to kind of keep it consistent. So actually the code here, this part is pretty much the same, except for that we have to do a pop instead of a delete, which, makes sense, right? And then after that, and this is what I wanted to do anyway, so after that, and I think we can also do Leetcode too, just so that we can do the running count here. So then now we can do append running and h, right? And then you add h, and and that should be good, hopefully. If not, then I'll be sad. But at least the idea is much cleaner. The expected answers. So maybe I'm off by a little bit. I have to debug this. Let me print prefix real quick. Right, but the idea is kind of the same, except for we're using a mono stack, right? So 5. This is already wrong. This should be. Did I not subtract the delta? Huh. So 5 is fine, right? And then 5 total minus 5. It should be 2. So yeah, I don't know why this is 1. All right, well, let's print it out real quick. All right. 5. Oh, why is it 0? Oh, okay. I am just dumb then. What I need is, I guess we start with 1 because we have 1 instance. Ah, okay. There we go. There we go. Lovely. Just gonna do math, right? So yeah. So now let's give it a submit. And that's pretty much it. So yeah, so I talked about this actually not that like a couple of days ago with respect to Monostack on I think actually the weekly premium prom. So definitely check that out a little bit. But the reason why this works, but this is not even relating to the Monostack per se, or there's nothing about the mono thing about it. It's just invariant of like, okay, going back and then compressing it, right? So the idea is just having a compression and just keeping track of the accounts so that you can pop them off only once per height. And yeah, now with this optimization, this is going to be linear time, linear space, right? Because this function is linear time now, and we do it twice, and then we do another linear loop. I'm going to check real quick. So this is the code, how much faster it is. But yeah, look at the difference. 8 seconds, or 8.2 seconds, 8.3 seconds, to under a second. So yeah, so this is a much cleaner way, Monostack. And yeah, that's all I have for this one. Let me know what you think. And you can watch me solve it the other way during the contest now. I've told is okay. Height is the maximum possible. It's a mountain if the index I it's very awkward phrasing, but I see it. Okay, fine. But it has to be equal to, so max height, max sum, okay. Okay. I think I get the problem. I think this is the length of max heights. What a sloppy constraints. Oh, this is only 1,000. I forget this is only Q2. It's Q3 have a bigger n. Q3 does have a bigger n. So might as well solve that first. How do I solve this? If thing is a mountain, then prefix and suffix, right? Yeah, okay, fine. Is that what we want? No, that's not what we want. That is kind of what we want, but we want it the other direction. It's kind of very confusing, actually. Is that what we want? We want 3. No, that's not what we want. What do we want? We want the min. Okay, I guess we don't start at 0. Okay. That's not right either, is it? What was I want? I want going out from here. Okay, that's probably what I actually want. So this isn't quite right. What I want is 2 or 3. Okay. And then 2 is going to be, alright, then it goes increasing. Right, so 3, okay. Okay, let's do the prefix first. I'm doing a prefix wrong. Okay, so that's 3, right? So what we want is prefix min. Well, this is the true part, and then it gets bigger. Okay. That's 3, and then it goes 2. I think I'm trying to do too much in linear. Let's just do it in sorted list. I mean, you can do it in linear, but I'm just struggling a little bit about it. And then what we want is no, this is not right either, is it? What am I doing? Okay, so then now here, let's say prefix plus h maybe, but right, so h, right? So if h is so previous max is equal to infinity, say, right? So then now max is equal to min of previous max, and then h if no, this is not right. Yeah. Okay, so if this number is wow, I'm just struggling today. It's 10 to the 1st. So is this DP? No, is this sortless? What am I doing? So we want like it's like an increasing thing, right? So if it stops there, it's gonna be 3, and then 2 is gonna be two, and 5, it's going to be 5. That's not quite right either. Oh. Wow, I'm just struggling on this one. I know a lot of people probably got that one already, but this one already, but I'm trying to do the harder one first. It's only in one direction, and then we could do the other one easily, but okay, so if it's this is TP, what is it? This isn't right. I guess you have to use. No, just okay, fine. I think sorted list is fine. Okay, right. So then now here we go. Okay. Prefix is 0. Okay, and then now okay, fine. Okay, let's do. Okay, I got this. But probably a little bit slow, but that's okay. And SL of -1. I think you can do this with monostack, but whatever. This is greater than H, then this is going to be right, but it's going to be n. This is going to be n squared in the worst case, the way that I'm doing it. Okay, I need a counter, I guess. Yeah. Wow, this is complicated. Could also use a heap, but yeah, maybe I don't. I think the sorted list is maybe a little confusing. Maybe I could use a heap then. Okay, fine. Let's use a heap. So then now, right. And then just something like this maybe. And do we want a min heap? We do. What am I doing? No, I know what I'm doing. Okay, sorted list again. Okay, fine. Let's do it with sorted list. Okay. H of -1, right? If intent. Oh man, this is such a mess. Just make sure that this runs real quick. Okay. Otherwise we H cap, right? Okay, and then wow. That's how it's greater than 0, and the max element is greater than H, then we want to trim the delta. Delta is equal delta count is equal to S of 1, and then this one's gonna be here. It's fine. Oh. This is this plus 1, and then now we want total minus no, that's not delta, that's just the previous, right? Delta is equal to previous minus H, so then now total subtract delta times count, and then we want to remove this. And we want to add yeah, okay, fine. Okay, and then now we wanted to one, right? This should always exist. So then now and this is wrong, this is right. And then now count running. Okay, and then now this is such a mess. Let's see if this is what I want. Okay. Oh wait, whoops. Okay, so now you have 3, this is 5, this is 10, this is 15, and then now you have 11 seems wrong, isn't it? Should be 10 and then 13. So why is it 11? Okay, it's a good thing that we actually looked at this, but still. Let's just see real quick. So we remove 5 for the previous, so the delta is going to be 3. There's 2 of them. Oh. No, that makes sense. So you minus 6. Alright, so then total is 11. What was it before? Off by 1 somewhere. Okay, so it's 17. Wait, it wasn't 17. Oh, it's 15. Yeah, this is 15. Wait, is it? No, this is 14. Oh, so this is not 5. Oh, this started off like really incorrect to begin with. So the 2, right? Huh. Actually, why isn't this triggering for this thing? Oops, debugging the wrong thing. Okay, so 3, 1 and then 2, 2. That's right. But we didn't do the math on the running. Or we didn't do the remove whole thing. Right. Oh, this is oh, I do have to check for this. If x is equal to h, then we can add this. Otherwise, that was wow, this is actually way sloppy. Okay, so then now this one is 3, 4, 9, 14, 10, and then 13. Okay. Okay. How many people have gotten Q3? 93. So I'm like not great. I think the answer is I'm close. Right, let me double check that one real quick. So that's 5, 6, 6 and 10, 4. Okay, that's good. Okay, then now we can do something like right? I like on different lines. Okay. Ooh, suffix needs to be reversed as well. Okay, so that's why we do it. Okay, so it's 1, 2, 6, 8. All right. Yeah. So what's the answer for the first one? 13. Yep, that makes sense. Okay. So then now it is 4 3x and 6. I guess you just max out, right? Could have been in one liner, I know. Just thinking about it. 13, 22, 18. Okay, let's give it a submit. I hope this is the same problem and I didn't miss something like silly. I guess maybe let's just focus on. Did I get the print statement in? I did not. Okay. I think I missed the prefix. Yeah. Oh, the input. Okay, same inputs. This times out actually would be a little bit sad. We wrote it this way so that doesn't time out, but alright. Well, thanks for watching. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, and everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.